Hey everyone, welcome back, and today let's solve Leetcode problem 2140 titled Solving Questions with Brainpower. So we're given a zero-indexed 2D integer array questions where questions at index I corresponds to points and the brainpower for that specific index I. Now, the array describes the questions of an exam where we have to process the questions in order, which basically means we start from question or index 0 and make a decision whether to solve or skip a question. Now, off the bat, what does that sound like to you? We have to make a decision or a choice whether to solve or skip each index, if you will. Off the bat, that should sound like a backtracking or recursive approach. Now, solving question I is going to earn you points, sub I points, but we will be unable to solve each of the next brainpower sub I questions, meaning we have to skip all of the questions after that specific index, and the number of questions we skip is going to be determined by brainpower at that index. Now, if we skip question I, however, we can simply move on or make the decision on the next question. We just don't actually solve the current question at index I. Now, they also give us a kind of mini example, kind of telling us what they really mean here. If, for example, our input questions is equal to the following, if we want to solve question 0, we'd get a total of 3 points, but then we'd have to skip the next 2 questions, meaning question 1 would be skipped and question 2 would be skipped, and we'd go directly to question 3 because we have to skip the next brainpower at this index questions, which in other words is the next 2 questions that we would be unable to solve. However, what if we just skipped question 0? Then we would solve question 1, the directly next question. We'd get 4 points, but then we'd have to skip the next 3 questions, right? We'd be unable to solve questions 2, 3, and technically 4, but since we don't have a question 4, basically just the last 2 questions. Because keep in mind, this is question 0, not 1. Now, we want to return the maximum points that we can earn for the exam, and that's, of course, going to be our output. So let's go ahead and look at the examples here. In the original input, we have questions to be 3, 2, 4, 3, 4, 4, 2, 5. It looks to be the same exact example that they give us in the problem statement as well. And in this case, 5 is the most number of points we can earn for the exam. Right? What is the kind of pathway we can kind of earn them with, or the specific indices or questions we have to solve to earn them with? Well, we can solve the 0th question. We'll skip the next 2 questions because that's what brainpower sub I tells us. We have to skip the next 2 questions, i.e. questions 1 and 2, and then we can solve question 3 for getting a total of another 2 points. Notice how that would be 3 points on question 0 plus 2 points on question 1, giving us a total of 5 points. 3 plus 2 or 5 points, right? That is actually the maximum number of maximum number of points to get. We can't earn more or equal even to 5 points using any other pathway. And to kind of prove that, what if we just didn't decide to solve this? We'd solve the question 1. Sure, we'd get 4 points. That seems like a lot, but we can't solve any other questions because we have to skip the next 3 questions and we only have 2 remaining, right? If we try to solve this first, again, sure, we'd get 4 points, but we wouldn't be able to solve the next question. And the logic still applies for this problem as well. And so this is the most optimal kind of pathway or pair of questions that we have to solve to maximize the number of points that we get. Hence the reason why 3 plus 2, 5 is our output. In example 2, we have our input array questions to be, in this case, we have 5 different questions, and in this case, we actually have a maximum output of 7. We can solve the first question here, getting a total of 2 points, and skipping these 2 questions, and then we can solve this question here, getting a total of 5 points, right? And we know 5 plus 2 is 7. That is the most number of points we can get, basically the most optimal pathway of questions to choose to maximize the number of overall points that we get throughout all the questions that we solve in the input array questions. So for the constraints here, we see that the length of our input array questions is going to be actually between 1 and 10 to the 5th power. That's actually very important because it tells us that really worst case we can have a linear time solution. Even n squared would give us a TLE, and so would any kind of factorial or exponential runtime complexity. Now, what do we know about BFS or brute force recursive solutions? They're typically exponential. And so although in nature this is an exponential problem where we have 2 choices for each index, either to skip it or solve it for each question, We can't really solve this directly with just pure recursion because it would get a TLE considering how large our input constraints really are. We're also guaranteed that every single question at any index is going to always have a length of 2, kind of just confirming what the problem statement told us. We're not going to have any invalid inputs. And finally, our points and brain power values for all indices are also going to be between the interval from 1 to 10 to the 5th power. So we kind of just first made that observation of basically for each index or for each question, we have exactly two options or two choices. Either we can solve the question, we can earn the points for that question, and skip the required next few questions that's denoted by that index. Or we could simply skip the question and move on to the next one without earning those points. Those are our two choices we have for each index or for each question in the input array questions, right? And what does that kind of lead to us? Now, another very important algorithm to know with this kind of recursive nature, if you will, is dynamic programming. It's very similar to recursion, except we store values and keep track of previously calculated values, similar to a cache here, to infinitely, or not, of course that's an exaggeration, but to make our solution a lot more efficient. Basically, we want to determine the maximum number of points we can earn at any given index or any given position in the input array questions, and we go there incrementally, hence the name dynamic programming. We kind of take it step by step and break it into sub-problems for each index, right? We get the maximum number of points for up until each index and effectively return the maximum stored at the very last index in the DP array. More on that later. Let's kind of first get into how we can kind of solve our problem in the most efficient solution. So again, we're going to use dynamic programming, still quite similar to recursion. Now, how are we going to really solve this? Well, basically, we're first going to actually initialize our DP array. It's going to be one-dimensional. In this case, it's going to represent, again, the maximum number of points that we can earn starting from any index I and for that given position. And we actually iterate backwards in this solution. It's going to be a top-down approach. Basically, we're going to iterate backwards from the last question to the first question, and we build our DP array using all the previously computed values for all the previously starting at each indice to go up until starting at the 0th index, right? Now, using those previously computed values for previously stored or cached indices, we're going to have at each question, again, two choices. We solve the question, meaning we earn its points, and we jump forward by the number of questions that it forces us to skip, which is, of course, denoted by brain power at that index questions, which is something we can deal with at that iteration, right? Our other choice, however, is just to skip the question. We can simply skip it, move on to the next question or the next index, and we just don't earn the points, and we just look for a different pathway of questions to choose from to potentially maximize our points, right? And effectively, the final answer is going to be stored in DP at index 0. That's going to tell us, again, the maximum points possible from the first question onward, because at the end of the day, it's most optimal to start from the first question and going to be the maximum number of points starting from the 0th question or the 0th index, right? That's why we have to return our answer in DP at index 0, because again, each index in the DP array is going to be the maximum number of points starting from that index I. And of course, we're always going to start with index 0 or question 0, and so we always return DP at 0 because that's going to be the maximum number of points that we can get starting from index 0 and building our values for each index incrementally based on previously stored values at previously stored indices. Right? So with that kind of high level rundown out of the way, let's go ahead and get into the solution here. So before I actually initialize my DP array, what I'm first going to do is actually grab the length of our input array questions. This is going to be, of course, basically what we base our dimensions of our DP array of. This is basically the number of questions we have. It's also going to basically determine the length of our DP array as well, right? This is really just going to help us iterate through the solution and build our DP array, just because I'm too lazy to type out length of questions each time I need this value, or this integer, if you will. Now, once we actually get or extract the number of questions, let's actually create our DP array. It's going to be initialized to all zeros. That's kind of like our starting initial filler value. And instead of having dimensions of n, it's going to have dimensions of n plus 1, the number of questions we have plus 1. Right? And each value is going to be, of course, starting with 0, because, of course, the maximum number of points is all going to be 0 starting up until any index I before we actually start computing values as we iterate through the input array questions. Now, why do we have n plus 1? Why don't we just have n? Well, we have that extra space because we can simply simplify calculations by voiding any index out of bounds error, because otherwise we'd go one index out of bounds, and that'll just make the problem a lot harder to deal with, because we could have Brainpower's index I that goes one out of bounds, which we don't want if we start at the last index, if you will, right? Now, let's actually begin our iteration, and like we talked about, we're going to be iterating backwards. So instead of for I in the range of length of 0, basically just starting from index 0 and going up until n, we're going to start from n minus 1 and go up until 0. And the way that works in Python is for I in the range of n minus 1 is going to be what we start with. We're going to go up until -1 exclusive, or up until 0 inclusive, or the 0th index, and we're going to decrement by 1 each time, meaning we're going to go 1 index less, or 1 index to the left in each iteration until we go up until the 0th index. Right? We're going from the last question, or iterating from the last question, which is index n minus 1, back to the first question, which is index 0. Right? This way we can actually use those previously computed values, if you will, for each index to determine the best answer or most optimal number of points for each index. Again, this is all incremental. This is all subproblems where each subproblem is its own index that we calculate step by step like we see in dynamic programming in general. Now, this is where we actually get the number of points and the number of indices we have to skip when we actually consider this index I. So the number of points and the number, or rather the brain power, in fact, I don't even need an underscore there, that's going to be questions at index I, right? This, I believe, is called unpacking in Python. Basically, we're extracting two values from the current index in the input array questions. What's important is that questions is a 2D array. Again, for each questions, we have two values and that sublist for that specific sub-index. We have the points, which is the initial value, and we have the brain power, which is the number of elements or questions we skip if we choose this question. We're simply extracting those values for the current question, where again, points is the number of points that we get if we solve the question, if we choose to solve it, and the brain power is the number of questions that we skip if we choose to solve this question. This is just simply going to help us make our choices, which is what our next kind of part of this solution is going to be. But before we actually start handling the logic for making those two choices, whether to solve or skip the question, let's actually calculate the option to solve the question. So if in some world, if we actually choose to solve it, what would that next question really be? Well, that next question would simply be brain power questions forward, because of course we have to skip the next brain power questions, and so we have to calculate it from this index onward. And so it's going to be the current index I plus brain power. That's the number of questions we skip, but we also have to add, sorry, there should not be an underscore there, we should also have to add +1 for that offset, because again, let's just take index 0 for example. If we choose to solve index 0, we have to skip the next two questions. So currently we're at index 0, and index 0 plus brain power at this index 0 is 0 plus 2, meaning we have to skip the next two questions. But look at this, 0 plus 2, the current index that we're at is 0, and if we skip the next two questions, 0 plus 2 is actually index 2. Now, if we go at this question, if we jump forward to this question, 0 plus 2, notice how it's actually invalid, because we have to skip the next two questions, meaning we don't jump from index 0 to 2, but rather we jump from index 0 to 3, skipping these two questions in between. And so instead of going 0 plus 2, we actually go 0 plus 2 plus 1 to account for that offset for the accurate number of questions that we have to skip. And so we'd have to go 0 plus 2 plus 1, which is 0 plus 3, which is index 3, so that's going to be the next index that we jump to calculate if we skip or solve this question. Right? That's why we have to actually add a +1 there. That's going to be the next question index if we actually try to solve this one. That's going to be the current index plus the brain power questions forward, plus that extra question to account for that offset for the accurate number of questions that we have to skip. Now, here is where we actually make our choice of solving the problem or solving the current question. But we can only solve the current question if it's actually in bounds. Like we see in this problem here, right? If we're currently at this question, if we chose to just skip these two questions, well, cool. We could get 4 points from this question, but we then have to skip the next 4 indices, or rather the next 4 questions. But that would actually bring us out of bounds, right? That's very important, and it's a very important logic to handle. We have to always ensure that we stay within bounds when solving potentially this specific index or this specific question. So I'm going to title it solve and explain it in a quick minute here. It's going to be the number of points that we have for this current question plus, and I'll put this in parentheses, dp at the next question. Sorry, okay. And again, we calculated the next question, the index of the next question, that is, on line 7. That's going to be the index, and we're only going to actually add this to the points if that next question is within bounds. How do we know if it's within bounds? Meaning if the next question's indexed, if it's less than n, meaning it's less than the number of elements we have. If it isn't, well then solve is going to be initialized to 0, right? Here, again, if we're trying to, the reason why I call it solve, again, is because this is the logic or choice of solving the current question, right? We're trying to solve this current question. So we can if we're trying to solve the question, the number of points that we get from this current index I, or this question I, is going to be added to dp at next question, right? Because that's going to be the next question that we jump to, the index rather of the next question that we jump to, because we have to skip the next brain power questions, which we already calculated the logic for on line 7. So we're adding the number of points to the next index that we jump to, but we're only going to do this if the next question is less than n, meaning if we don't go out of bounds. If we go out of bounds, well, then we simply add 0, right? We simply add 0 because then we simply just take the points from the current question, right? Again, if the next question is within bounds, we'd add dp at next question, which would be the best answer from that point onward. Or, if that isn't the case, we simply just take the points from the current question, so else 0, right? Again, if dp at next question isn't in bounds, we simply just do points plus 0, which is nothing but the number of points for this specific question. And this is the logic for if we actually do end up solving, or solving this question I. But what if we just choose to skip the question I? So I'll title it, you guessed it, skip. If we skip the question I, it's actually a lot simpler logic. We simply just move on to the next index. And quite simply, how do we move on to the next index? Instead of, if we're at the index I, we simply move on to index I plus 1. So skip is going to be dp at I plus 1. This is the value that we get if we just skip this index and move on to dp at the I plus 1th index, the next question, right? If we skip the current question, well then of course our best score is simply going to be dp at I plus 1, which should also be the best solution from the next question onward. That's going to be the second choice that we have. And now, whichever value is better, solving it or skipping it, we have to actually update it for this index and store it as the best choice in our dp array for this index I. So we'll get dp at I, and it's going to be the maximum of these two choices. It's going to be the maximum of either solving this question or skipping this question, whichever one is the better choice or the more optimal number of points for this index I, or for this question I, right? We're basically going to get the maximum of solving the question. If that gives us a better score, we'll take that. Otherwise, if we just skip the question, we'll take that score, and we'll simply maximize whatever the values in those two values and set that to be the maximum number of points that is starting at this index I for this index I's choices. And effectively, how do we return our final answer once we iterate through all the potential starting indices in the range from I-1 to 0? It's going to be stored in dp at 0. Why? Because of course we always start with the 0 with index or the 0 with question, and that's going to be the best possible score starting from that first question, which is going to be in dp at index 0. Again, keep in mind it is 0 indexed. So unless I made it in the syntax 0, 0, there should be accepted and there should be a valid solution. So let's go ahead and double check that. And as you can see, this really is just about as efficient as you can get it to be. Again, the reason why we simply just didn't have a recursive solution, literally just going through all the potential choices of solving or skipping a question, is because that would actually be a exponential complexity, because we wouldn't actually store previously stored values or cached values in a dp array like we saw in the dynamic programming problems approach and solution, and that would not get us that would get us a TLE, because as we can see, an exponential solution would not work for a 10 to the 5th power time constraint for the input. It would just be way too slow, right? So that brings us to, how does this solution really work as a whole? I do understand that dynamic programming can be rather difficult. Let me kind of break down how we really solve this problem. First, once we actually initialize dp to be all zeros with dimensions of n plus 1, we then iterate backwards from the last question, n-1, to the first question, which is nothing but 0, the 0 with index, or the 0 with question. And once we actually get the number of points that we get from solving this question, and the brain power, or the number of indices that we skip if we choose to solve this question, and we also get the index for the next question if we choose to solve this question, we decide whether we want to solve it or skip it, right? That's kind of the two options or choices we have for each index I. And we do this by using those previously computed results for previously calculated or computed indices that are already in our dp array to make the most optimal choice. Either we solve it adding the number of points that we get from the current question of dp at next question, only if that keeps us in bounds, meaning the index of the next question is still in bounds. Otherwise, we simply add 0. We basically just take the number of points for the current solving logic, or we simply skip it by just taking dp at I plus 1. right? Kind of skipping this question and just taking the next question's most number of points, starting from the next index, right? And basically, we're gonna have the maximum score stored in DP at index 0 by the time we actually return, because that would be that's of course what we're gonna have by the time we reach the first question. That would be the maximum number of points that we can get starting from the 0th or question or 0th index, and that is going to be the maximum or output value for the problem. Right, it is a very classic dynamic programming solution. It is a little bit difficult to see at first because I do kind of paint this out to be just a straightforward recursion approach, but you have to be able to see that recursion is just too inefficient for this problem because it does have an exponential time complexity by looking at the input time constraints. So that brings us to the actual runtime and memory complexity. For the runtime complexity here, fortunately, it is actually linear. It is really just a linear time big O of n solution. Why? Because, well, it is just a single pass solution, right? We have one singular for loop here. We iterate through each question exactly once as each potential starting index, right? And of course, at each step, technically, yes, we are performing some addition and some if conditionals here, some maximizing, some updating, but those are all just constant time big O of n operations. They won't actually affect our runtime complexity. So the overall runtime complexity is big O of n, just linear, and the memory or space complexity is actually also going to be linear. Why? Because look at this. We literally have a DP array of practically just exactly dimensions n. We do have that extra spot, but basically it's going to have roughly an size or auxiliary memory extra data structure of size n, and so the memory or space complexity is also going to be linear in big O of n. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And I do realize that this was rather a longer video. Sorry about that. And without further ado, I will see you guys in the next video. Bye bye.